So this is our 5th year at this venue, and we began a tradition 5 years ago of kicking off with a forward-looking session, which is enjoyable to do. It's a great pleasure, because as you look out 5 years, you can make these pronouncements, which can't be proven wrong, and everybody forgets. So I've enjoyed this quite a bit. What I'd like to do this time, though, is combine that and actually look at what were these predictions that were made going back, starting with 2015 in our first one, and to see how these hold up. So the first notable one in 2015 was that we had identified that we were really at an inflection point in the market, that clearly BPM, as we understood it, was undergoing change, and that there was this emerging set of capabilities and the need for new labels. Up to that point, the notion of automation was largely anathema. And we talked about that being something that we needed to get away from, that we needed to focus on agility and adaptability, and that automation was seen as something that was fairly rigid and not very smart. So I think I coined this phrase at this time. If anybody can disprove this, I'd actually like to know, but looking for what was the label for this new generation of BPM in 2015, we described it as intelligent automation, which now has become the term of art and the contemporary way of describing what we're doing today. And it's something that is inherently data-driven, that it's goal-oriented, and that it's adaptive. In that same presentation, and what is held up over that time, is I coined what I called the 3 R's for BPM and for intelligent automation. That the challenge for BPM and the new problem set that we're looking at is how we integrate and leverage the interrelationship between rules, relationships, and robots. Now, in 2015, this notion of robots being meaningful participants in our work was something that we all could envision, but seemed really far away. Yet, in that time, we've seen that, indeed, the robots are, frankly, are here. We had actually integrated robots being driven by BPMN in a presentation last year. And the discussion around robots now is really dominating. And there's a lot of fear and angst around robots, not just from the standpoint of displacing work and workers, but this notion that robots are fundamentally scary in their disruptive nature to our operations, to our processes. But the reality is robots aren't really that scary. That the fact is robots are inherently driven by rules, that robots require rules to be able to work in the organization. And that's what we've seen now with the emergence of intelligent automation as a means for managing robots as part of the digital workforce. We started to use robots and AI interchangeably. And the reality is AI, today, typically when we say AI, we're thinking in terms of learning systems, of machine learning and neural nets. And when we're talking about robots, we're talking about something that is very prescriptive. We can call RPA deterministic AI, in that it's something that's driven entirely by instruction sets. We don't have RPA that's out making decisions on their own other than that which is driven by business rules, where we are using AI to be able to bridge the gap where we have ambiguity around rules. So from the standpoint of RPA and robots, that the R is for robots, the R is also for rules, that rules are inherently unambiguous, and that there's no room for nuance or ambiguity with robotic automation. So one of the predictions for this year is that, and this is not a very controversial prediction necessarily, but it's one that I put out there to think about, and hopefully we come back next year and the year after and look at this and think about how this is changing, that at least half of our work and our interactions, our commercial transactions, our business-to-business transactions, and actual production work will be performed by a digital workforce or by robots. So the third R is for relationships. And when we were starting at this point in 2015, BPM and software architecture still had a pretty heavy integration component. But we're starting to see the shift towards providing intelligence to know how to get data as opposed to having to replicate and store that data locally. And increasingly, we see this as a driving element for both intelligent automation and likewise intelligent automation as a means for enabling this. And when we talk about digital transformation, a still generally ambiguous term, this is one of the fundamental aspects of it, the notion that if you think about your customer, that we no longer have a customer data repository. We have the means to define that customer, but the dimensions of that customer exist in a multitude of systems, many of which are outside of our control. And at any given time that we need the context about that customer, we don't go to our local store alone. We might be going there for guidance and to know where to look. But ultimately, we're pulling in data from a variety of sources. And when we're acting on that in the context of processes and automation, that we're interacting with systems that are outside of the span of our control. So our next prediction is that by 2022, and again, not entirely controversial, we're pretty close to this today, but that the majority, at least approaching or exceeding 2/3 of commercial transactions will be occurring on systems that are outside of our span of control. That our core means of conducting business will rely not just on a third-party cloud system that we are engaging. In this case, we don't mean cloud as a service as much as it is the external systems and external edge points that are part of our business ecosystem, and that our end-to-end process is engaging with these systems that are outside of our span of control. We did research that we're about to publish that we conducted last quarter, and one of the focuses of this was to look at, for customers today, how many systems are required to represent a customer and to perform core work. And that we found that the average number of systems required to conduct core operations is just over 13. But the majority of those are external to operations. And that the vast majority, 80%, cite 10 or more systems. So we're already at this point now where our core business is reliant upon the coordination and orchestration of systems that are outside of our control, and that's a fundamental opportunity and problem statement for intelligent automation. So the 3 R's that in 2015 we said ultimately would define the future of BPM, these are also what's critical to the definition of intelligent automation. That the role of robots and robotic software and rules and relationships are what ultimately define at a high level, and that's at a level, intelligent automation. At a more detailed level, what does intelligent automation look like? We started putting together a framework that we evolved a little bit year over year. The first version of this was in that initial discussion in 2015, and now it's at a point where I think it's fairly mature enough that while we may change some of the labels and some of the orientation, that fundamentally this is the framework that's going to define this architecture for intelligent automation going into the next 3 to 5 years. So incorporating RPA not as the platform, but as a component, as a pillar of that platform. similar AI and machine learning, as well as decision management and process management. Basically, these four components existing as essentially equal and first-class citizens of that platform, and using an event pipeline to feed into that. Part of our discussion, this will be part of the panel that we'll do later this morning, and over the course of the next 2.5 days, there's not a single session about this, but sort of implicit is this notion of what's core today in terms of what is differentiating technology versus what is commoditized. I will argue, and the reason why these components are there, that these four components are core. They're not necessarily a single suite approach or required from a whole product standpoint, but as capabilities, these are where innovation is being driven and focused. This is not where it's commoditized. That event pipeline, which just a few years ago really was core, the notion of having that mediation tier as a means to pull these things together, that's what's differentiating or is commoditizing, and that's where we see this becoming a core part of the cloud platform. As we look at this, one thing should stand out, and I would want this question to be going through your mind, that there's something that isn't called out here that I think is conspicuously absent. What is it? So when we look at this, where's the interface? And there's two dimensions to this answer. One, the role of what we're calling process management. Traditionally, this is the box for BPM. BPM is an evolving definition. So all of this is BPM, parts of this are BPM. I'm less concerned about that, but we can identify that that there is a tangible, palpable BPM software set, and a core part of that is providing the UI. So BPM, part of its role is to provide the framework for work management, to manage control flow, and to manage assignment of work. But the other part of it, in terms of the user interface, is that it is all of these pieces at the bottom. Did I exceed my time? All right. So BPM provides the UI. Today that's true, and that's a fundamental role of BPM. But the other aspect is that the UI is all of these things, and that there is a loop here on purpose. And in fact, that's part of this fundamental transformation of both architecture and the orientation as we shift from BPM as a discrete product set to this notion of achieving intelligent automation as an outcome of how we're leveraging these technologies. So our third prediction is that by 2022, the majority of user interactions will be on devices other than a smartphone, which is the operative distinction there. Obviously, that also means laptops as well, but through some other device. Not sure it was 2015, but a few years back, again, intentionally polemic, intentionally controversial, said we need to anticipate that we're facing the death of the smartphone. And at least for the last 3 years, I've said this year over year, and it seems ridiculous in that we have reached a point where we live our lives through the lens of our phone. Yet we're starting to see it. We have the economists celebrating the end of the smartphone. We have the Anglican Church identifying that, in fact, it may be the Antichrist, or a portal to the Antichrist, which obviously is no surprise to anybody. So the end of the smartphone is coming. Not sure the Antichrist is coming, but the end of the smartphone is coming at least as the dominant platform. So what's next? We've had in roughly that same time frame. I can't remember when the Echo was first introduced, but if you remember when the Echo was first introduced, what a ridiculous device it was. This really expensive Bluetooth speaker that served no function other than you could add items to your shopping list and get generally wrong answers to very precisely worded questions. But over time, we've had this new category of smart speaker evolve, and it's an explosion of different interfaces. And what is happening is it's changing our interaction to a conversational mode. And we've been talking about this notion of conversational commerce and natural language processing for a few years now, but we're on the cusp, largely driven by the consumerization of the user interface, to the point where expectations will be framed around a conversational interaction pattern, which is inherently dynamic and context-driven. Forget how silly it is to talk to Alexa or Siri or otherwise in terms of having actual conversations. What's critical is the fact that it is inherently dynamic, context-driven. It's not linear. We can see that contrast in the way that IVR systems now are deployed. If you get into in a consumer transaction, you dial into an IVR system where you're now having to navigate through this predetermined tree. How many seconds is your patience going to last? The expectation today is that we can ask a question in a natural language way. And what's happening from the standpoint of the business logic behind that, a far more complex consideration that's largely driven by rules and increasingly, and should be, by more formalized decision logic combined with AI to be able to guide you to generally the right answer to the question, and then being able to do that with some control, so you're actually getting an accurate answer. Very different than a pre-programmed decision tree. And in the same way, expectation is changing both for consumers and for employees for how we're going to be interacting with processes, to have that same dynamic ability as opposed to having the structured work list metaphor that's defined process interaction for the history of this industry. So our next prediction is that by 2021, in just a couple of years, that the expectation, the dominant expectation, in the same way that today you are expected as from a employee-facing system, other than that which is purely heads down in production, and certainly from a consumer-facing system, you're expected to be universally accessible, at least from a mobile standpoint, that the same level of expectation will be in place, that you'll be able to engage in this conversational way. So that changes our process and our software architecture in pretty profound ways. That ultimately requires re-envisioning the notion of the task from not being a discrete unit of work, but ultimately to remove that distinction from what it is that we're doing and the means by which that we do it. And ultimately, who's performing that? So that the same work and the same systems can be acted on by external parties, internal parties, and non-human parties. That we be able to apply a robotic automation to our core systems, which from a software architecture standpoint, looking at where we are today, the innovation that's represented in this room and what we've evolved to from the standpoint of intelligent automation, that is not very far-fetched. From the standpoint of the business analyst and how they approach ways that we design and improve our systems, that is a pretty big leap. So we need to accommodate the fact that from the standpoint of competitive pressure and keeping up with that we increasingly will be competing with a digital workforce. And our ability to enable that from our standpoint changes fundamentally the way that we approach process design, and as well as obviously system design. But systems are frankly further along in the ability to accommodate this. The further reach today is how do we actually envision this and design this? I made this prediction last year, and I'm repeating it again, that the part of this notion is that the way that we expose our capability and our value is through decision as a service. I don't mean a rule engine in a platform as a service way, but the idea of being able to provide well-informed decisions is a core means for, particularly in public sector, in health sectors, in service sectors, that today so much goes into the packaging and delivery and interfacing of an answer, that more and more that this will be a core capability that defines the value or the offering of a particular organization. But to get there, and this is a discussion that we're not going to have at this moment in this presentation. We began this last year. We have some sessions to talk about this. My colleague Lloyd Dugan will be talking about this Wednesday morning with some work that we're doing. But we haven't yet even created the basis of the answer for this. I think that this is the core challenge facing our industry right now, is how do we describe these new process automation capabilities in a way that we're able to bring together the combination of automation and intelligence in a way that is accessible to business analysts and those that ultimately should be driving the operational understanding of how we're going to apply this. We're going to see some pretty innovative stuff in terms of the combination of DMN, BPMN, and CMMN. I don't know that we need another notation. I think that those three notations together provide the notational side of this, but from the standpoint of the discipline behind that this is a critical area for our industry. When we think of process today, and those in this room can quickly see beyond a traditional workflow metaphor to defining process. But the reality is that our transformation initiatives ultimately still produce a lot of stuff that looks like this, where our processes are defined inherently based on sequence, and in many cases tasks that aren't work themselves, but are decision points. And it's ultimately the decision points which define the work and define the sequence. Yet, for the vast majority of not just the industry in terms of those that are represented in this room that are committed to advancing this notion of intelligent automation, but in the broader sense, the adopters and those that are putting in place this technology in their organizations, we still think largely in terms of sequence flow and a flow chart metaphor. But when the reality is for intelligent automation that there is a inherent statelessness and lack of sequence in the combination of how we're applying context with rules and policies to inform how work should be performed, and ultimately doing that in a way that doesn't prescribe how that work is done, who that work performer is. That it's about achieving outcomes based on the operational context of work at that time. And that's, again, why I say that our fundamental challenge is being able to provide in a way that's accessible and consumable to the much larger audience of business analysts and others, ways to depict business outcomes without having to be wedded to the flowchart metaphor, but that shows the combination of automation and intelligence and ultimately decision logic. To use a real-life example of this, and Waze as a metaphor for processes has kind of been done to death. We've talked about that when we got into more analytic-driven processes. I remember giving a talk at the first BPM Next event that we had in 2012 or 2013, 7 years ago. And coming out of that was this discussion of how ultimately the next generation of BPM is going to look a lot like Waze. That we've got this combination of real-time intelligence with a process, with dynamic interaction. And I agreed with it then, I agree with it today, but it missed the point. And part of that point is the fact that Waze is not useful simply when I don't know where I'm going. That ultimately Waze is most useful, most valuable where I know where I'm going, but I want to get there faster. Who else does this? You put in the destination at Waze and you get the ETA. The minute you get that, what is your goal? Is to beat that ETA. That defies the notion, other than driving faster, how do you do that? If we think the basic notion of a GPS system, you've got 2 points, and it's coming up with it's using a linear programming algorithm to say, this is the fastest way to those 2 points. But the reality is that there are all sorts of course corrections along the way that are fundamentally going to make that difference. And I'll use a real-life example here. That's a screenshot from my phone, and the ETA at that moment was 8:22. So I'm driving to the airport. And as my wife will attest, I'm not one of those get there 2 hours early kind of travelers. I'm usually right on the cusp. And I'm driving to Boston Logan from my home. I live on the South Shore. And there's 2 basic routes. One that adds about 30 minutes, but it's consistent. And that's where I have to go further inland and get onto major highways. And the other is to hug the coast and to take largely back roads, which generally is consistent. I've been driving this route for decades, and I have a fair amount of comfort in how long it takes. So I'm on my way, and I hit a black swan event. I come up to a drawbridge that just as I arrive starts to open. I know enough about this drawbridge and this route that now I'm faced with 2 scenarios in both of which the outcome is I miss my flight. I can sit there and wait for the bridge to close, which is 25 minutes. I can pull a U-turn and go back the known route, which is 30 minutes. At that point, I didn't have the margin for an additional 20 to 30 minutes. I had maybe 15 minutes to be able to get to the airport. So at that moment, I had pretty much resigned that I've missed my flight. But I didn't give up. I said, I'm going to trust Waze. So I pull a U-turn, and I don't follow the known route, and I have to go quite a ways to get around this drawbridge. But I just start heading in a way that kind of seemed logical, and I want to see how Waze recalculates. And it does. So as I'm going along, it's constantly refactoring and figuring out, and the ETA is bouncing up and down. And it's taking me on a route that I could never recreate. I generally knew where I was, but there's no way that I could have retraced my steps. But what's important in this context is I wouldn't want to, because that route mattered and existed for that moment in time. It wasn't the linear programming algorithm that says, from this point to that point, this is the shortest path. It was based on real-time data and applying that against machine learning. That was the best route at that moment in time. And in fact, so when I made that turn, and I took that screenshot, and you could see that I'm veering left. It was 8:22. I arrived at the airport at 8:23, which is mathematically, scientifically impossible. I don't know how I could have shaved that amount of time, but I did, because Waze was able to figure that out. And when we think about this core value proposition for intelligent automation, that ultimately it's about being able to make the right decision and take the right action sooner. And this I've talked about for some time, that when we look at this notion of intelligent automation allows us to respond to events, and that every event has a half-life, that the value of that event, the longer it takes to respond, the less value there is in that, and that there's not a consistent scale other than we know that it's not linear. That we start to lose value a lot up front. So by shifting that to the left, we're able to gain a lot more value. Or in another way to look at that, and this comes out of long-standing work in looking at the value of analytics, but in the context of intelligent automation and machine learning, if we think about it from this standpoint, that greatest loss of value is what's happening in the early stage. And that the value to be gained later, where we're taking action on that event, is far less. It's going to be a fraction of the value lost or otherwise value to be gained from what's happening in the upfront part. So where automation traditionally has been applied to making that action automated once the event is understood and that the best action is identified, that's not where we're going to gain or lose value. That ultimately it's about how we understand and determine what is that best action. That's where the value is most realizable. And so when we think about how we can apply machine learning to make our processes better, it's not necessarily about automating the action and using AI to do things in a way that's closed as a black box, as it is being able to take and understand that event faster and determine the best action. And at that point, whether that action is automated or acted on by a human being or acted on by some other facilitated action, that is far less important than being able to understand and come up with what is the best action to take. And so applying machine learning to that, and we think about it in terms of the way that it works, that doesn't necessarily mean that every event is then evaluated by machine learning separately and that action is determined in an automated way. Working with BPM and how BPM is facilitating user action on that, we can start to apply filtering to events and understand by applying human know-how to what that best action is, and to come up with the patterns through the way that we manage work, and then fold that into the ability to understand and evaluate events. So with Waze, I faced a black swan event an unpredictable event that was highly disruptive. By applying machine learning, we can shift to this notion of anti-fragile. Who besides Keith has read Taleb's book, Anti-Fragile? I think is, although it got much less press, I think far superior to Black Swan in that it presents this notion that absolutely applies to what we're facing today, which is that we can have a stronger organization by applying and leveraging intelligent automation with machine learning, by understanding how to respond, and where every event makes us smarter, more responsive, not more rigid, not more fragile, but able to withstand disruptive events far more easily. The problem is, with machine learning, and what we've been seeing, is that it's only as smart as our understanding of those events. If we look at examples, some of which, if we look at famous examples that have come up in recent history, one of them actually I stole from Sandy, who brought this up, but it's a brilliant point. Amazon, who had faced a tremendous amount of pressure in trying to staff up and recruit, not so much for their across the organization, but Amazon is now one of the largest employers and has these surge in employment processes. So the ability to apply AI and machine learning to expedite and accelerate that would offer a tremendous amount of value to Amazon. But what came out of their practice was that rather than having an impartial and unbiased AI, that the system was actually more biased, more sexist than the human beings. And similar to the chatbot that Microsoft released, where in the first 24 hours, it went from being this sort of cute, docile, artificial interaction to this super racist Nazi chatbot. And in both cases, it's the data that's being fed into the machine learning algorithms that are affecting how decisions are being made. So getting the data right and having an understanding of that is critical to the ability to leverage machine learning. So one of the things I came up with recently is an algorithm that looks at some basic checkpoints into determining whether or not the data is there to be able to leverage machine learning. And the most fundamental notion is, with the volumes of log data that you would logically be using, do you have work that's composed in a way that actually looks like a process, where there's measurable tasks? And most often, the first test has failed. Most often the answer is no. And there's a whole emerging crop of companies that are providing ways to elaborate your existing log data and to turn that into training data. But one of the basic, most innovative ways to do that is to apply process mining, and to be able to use that to come out with an actual sense of the work and the tasks and the causality around that. Then the second is whether or not there's a large volume of a large enough volume of data. And in most organizations, this is the second biggest challenge, and ultimately the answer there is to generate more data, but not just generating more data. As critical is being able to validate whether or not there are patterns that can be recognized within that, and being able to do it beyond just identifying the processes. And we'll see examples of both of this over the course of the next couple of days. But to be able to recognize patterns that we're validating as filters and how, what we're going to be training against, there would use data mining and to be able to isolate that. And then the last is whether or not are the patterns that we've identified, these precise enough that we can take action on that. So one example where machine learning is being applied today, here's the simplistic example, identifying kittens. So that was Google's first use case with deep learning, was to be able to pick out kitten pictures out of huge volumes of data. Whether or not it's a kitten is deterministic. It's unambiguous. What kind of kitten, whether it's a cute kitten, what color kitten, those are things that fall into more the probabilistic category. But when we're looking at processes, do we have a discrete answer? We're not looking for kittens in most of our business models, sometimes, but not very often. But we are looking at being able to determine whether or not it's something is an invoice, or whether or not things that have fairly discrete parameters, or we're coming up with levels of confidence where we can't say for sure what something is going to be, but we can use guidance to be able to drive decision support, to be able to help triage work and identify these things. So these are our basic gateways or checkpoints for determining whether or not we have machine training data available. But an important point for us in this room, for the industry, is that where in most organizations there isn't well-formed data in most systems, where we have a great wellspring of machine learning data that can be folded into this is what's being generated by BPM and intelligent automation as a platform. But this is an inherent advantage in the capabilities of the systems that we're talking about this week. And we're going to see presentations about that. So just wrapping up, ultimately, and I'm not going to go through each of these, but just kind of a summary of takeaways that RPA is inherently rule-driven and needs to be looked at that way. That it should be driven by decision logic, not simply by automation scripts. That a core focus and a core value statement of intelligent automation is how we're able to pull together and make actionable data that exists in separate systems, and ultimately redefining the way that we look at work in a way that is distinct from how work is performed versus the outcome that is being achieved. And part of that is changing this orientation from thinking of tasks and work in terms of who's performing the work, but rather defining it in a way that can be performed by any entity, ultimately including humans or robots. And that probably the most key aspect for how we're going to be leveraging AI and machine learning with intelligent automation is creating this closed loop environment where we can get that advantage and learn from the outcome and the actions that are taken within the systems that are human facing, so that we can start to apply that in a way that expands the envelope of what is automatable, and ultimately folding in more work that is intelligently automated rather than the old way. So I'm going to end on this last point. I used this quote last year, and somebody said to me that the person I attributed it to, that actually didn't say it, that it was Einstein, and that's being cut off from the screen there. This question mark after that. I don't think it's Einstein. I like this picture This is the picture that's adorned millions of dorm rooms across the nation. But what's funny is that he's riding a bike about a mile away from here in Santa Barbara. But no, it wasn't Einstein. In fact, it probably was Alan Kay that said this first, but Drucker said it best. And that ultimately the best way to predict the future is to create it. And this is one of the quotes that I love to end with. But particularly as we're talking about the last 5 years of predictions and what we've been looking to in terms of how the market's evolving, that we've done it. I say we, I had very little to do with it, but you in this room have done it. That the predictions that we've been talking about from 2015 up through last year, that is represented here today, meaning right now. Over the next couple of days, we'll see it. But ultimately, this event and the turning point that we have hit as a market means that this event really is a celebration of making these predictions a reality over the last 3 years. So I'm going to end with that. Thank you.